Do you develop distributed applications or systems made up of lots of microservices? If so, you've surely had to deal with issues where users complain about the service being slow. In a distributed system, it's often hard to figure out which dependency is causing it. This is where distributed tracing comes in. We covered using OpenTelemetry to capture and analyze latency from distributed applications in the previous episode. If you haven't watched it, we'll link to it in the episode notes. But in brief, we want to create traces for user requests and spans for the service-to-service requests, whose latency we want to analyze to determine which services may be contributing the most to the overall latency experienced by our users. OpenTelemetry is an open source library that allows us to easily instrument our services and capture traces from them. My name is Yuri. I'm an SRE at Google Cloud, and today I'm going to show you 2 ways to instrument your services with OpenTelemetry. I'll cover easily getting started with automatic instrumentation and using manual instrumentation for maximum control. Welcome back to Engineering for Reliability. Let's have a look at a simple application that has a front end that serves user requests and makes its own requests to a back end to retrieve additional data. We'll use this for both of our examples today. So ideally, we want to capture the latency of the overall request as perceived by the user, the latency of the back end request as seen by the front end, and how long the back end processing takes. The front end of our application is written in Flask, and it uses a request library to make back-end calls. The back end is also a Flask app. When it receives a request, it does some processing before returning a response. To use automatic instrumentation, we can run both our front end and back end using the opentelemetry-instrument command. The command will try to automatically detect packages used by our code and apply automatic tracing instrumentation on them. We get distributed tracing exported to CloudTrace without having to make any code changes. Let's take a look. Our front end is running locally using the opentelemetry-instrument command, instructing it to send traces to CloudTrace. And the back end is running locally as well using the same command. Let's send a request to our application and confirm the response. In the CloudTrace UI, we can find the resulting trace. It's comprised of multiple spans. The root span is the overall request. And we can see how long it took. It was made to our service running on localhost on port 8080. The first child span is the backend request. It was also made to localhost, but on port 8081, which is where our backend service is running. So this is how you can use OpenTelemetry automatic instrumentation to capture traces across distributed services without the need to modify application code at all. That was really easy, but there is a caveat. We couldn't create a custom span to time backend processing without adding instrumentation in the code. So let's have a look at how you can manually instrument your service to explicitly control how spans are created. We'll link to the full code sample in the episode notes, but let's start by reviewing our front-end code. First, we need to import the necessary OpenTelemetry libraries that will let us manage spans and context propagation between our services. We'll use the request context to send information about our trace to the backend so that it can append its own spans to it. Next, we configure our exporter to send traces to CloudTrace. Finally, we're ready to make our backend request. We create our root span that will serve as the parent for the subsequent spans. Next, we create a span specifically to time how long the backend request takes. Lastly, we make a request with HTTP headers that will carry the span context to our backend. In our backend service, we first extract the span context from the incoming request headers. We then create a dedicated span using that context to time how long our backend processing task takes. Now let's run our services and inspect our trace in CloudTrace. In this example, we also have our front end running locally, but this time we're using the basic Python command. Our backend is also running locally using the same command. We can confirm that our application is responding by sending a request and confirming the response. Now we can go to CloudTrace and find the resulting trace in the trace list. The trace has our root span, the backend request span, and now a dedicated span for backend processing. For each of these, we can see exactly how long they took, which allows us to figure out exactly where the time is spent in serving the user request. So this is how you can use manual instrumentation with OpenTelemetry to send request context over the wire and use it to append child spans from downstream services. Thanks so much for watching today. We'll learn how to use both automatic and manual instrumentation with OpenTelemetry for distributed tracing of our Python services and understand latency in distributed application. I hope this helps you to keep your services reliable and your users happy. Don't forget to like and subscribe to never miss out on more engineering for reliability with Google Cloud. See you soon.